Hi, I'm Jessie, and today I'm going to talk about calorimetry. Calorimetry is used to measure the heat of a reaction, heat of fusion, heat of dissolution, and the specific heat of a reaction. To find this, you'll need to use the calorimeter. In a high school lab, a calorimeter will most likely be 2 styrofoam cups. However, you could also use a bomb calorimeter. The difference between these is that a bomb calorimeter will be used when gases and high temperatures are involved. In the real world, calorimeters are used to find the amount of calories in your food. A bomb calorimeter will burn the food and use the heat to warm the surrounding water. By finding the change in temperature, you can determine how many calories are in your food. Alright, so for this problem, we're given 335 grams of water at 65.5 degrees Celsius. It will lose 9,750 joules of heat, and we're asked to find the final temperature of the water. So the first thing we're going to do is set up our heat equation. So we have 9,750 joules equals 335 grams multiplied by our specific heat capacity, joules Celsius, times delta T, which is what we're trying to find. So if we multiply this out, and first if we cancel out all of our units, we're given degrees Celsius, which makes sense since we're finding temperature. So we have 9,750 equals 1,401.64 delta T. And if we divide 1,401.64 we are given with delta T equaling 6.96 degrees Celsius. However, we're not done yet. We were asked to find the final temperature of the water. So remember, if it's final minus initial, we'll have to go negative 6.96. This is negative since we're losing heat, as it says here, losing heat. Final minus initial, 65.5 degrees Celsius, equals 58.5 degrees Celsius. So that is the final temperature of the water. Alright, so our next equation is asking for it says that the temperature of a sample of water increases from 20 degrees Celsius to 46.6 degrees Celsius as it absorbs 5,650 joules of heat. What is the mass of the sample? So first, we're going to find our delta T since we're given two different temperatures. So delta T equals our final temperature, 46.6, minus our initial temperature, 20 degrees 0. And that gives us 26.6 degrees Celsius. A positive answer makes sense as we're absorbing heat. So now if we set up our heat equation, we're given Q, which is 50 joules, equals 4.184 joules grams per Celsius, multiplied by our mass, which we don't know, multiplied by our delta T, 26.6 degrees Celsius. We can start now by eliminating our units, or canceling out our units. So joules cancel out here, degrees cancel out here, and we're left with the grams, which makes sense since we're finding the mass. So now if we multiply this out, we have 5,650 equals 111.2944 M. Divide 2,944 2,944, and our mass, rounded with 6 figs, is 50.8 grams equals 10. Finding heat equations in the variables are very simple algebra as long as you realize what variable goes with which. So Q, 5,650, delta T, final minus initial, and the specific heat for water is something you'll just have to memorize, but will be easy as you use it in many equations. And then you'll have to find another one.